好的伙伴，也是呢来自呢我们这个东南亚区、亚太地区这个数据科学、人工智慧创新的佼佼者。我们要欢迎的呢，就是来自呢 Avitis Data Innovation 的主管 David 来为我们深入探讨 AI、ML 在呢我们的洗钱防治 AML 的合规性、监管指南，以及呢我们的统计还有实际应用的领域。那我们现场呢就把掌声送给 David， 欢迎。
大家好，我叫 David。接下来讲的话题可能稍微复杂一些，但是主要就是想看 AI、ML 是在合规领域里面，就是反洗钱合规领域里面是在哪里用到的，然后看一下真实的 use case。但是我可能会用英语来去 present， 因为这个讲起来可能更流利一些，对，不好意思。Okay, so I think the main topic, the main takeaway for today's presentation really is about when thinking about AI, it's not so much artificial intelligence, really it's augmented intelligence. Augmentation, how do you support your workflow processes? So I think there are a few key terms here. It's process, it's people, and it's technology. These are the key concepts that we'll touch on later today. But that's the main topic to really think about it. And I don't know how many people here are familiar in using in AML and anti-money laundering and in the world of anti-money laundering, but I know there are many of us from banks and this is a hot topic. But I myself, I've been with the world of anti-money laundering for, say, 12 and a half years. And I can pretty much summarize anti-money laundering into three E's, the three E's. And what does it mean? So you have efficiency, effectiveness, and explainability. And they sort of counteract with each other. They contradict. So oftentimes, if you want to be more effective in anti-money laundering, right, you want to catch more, raise more alerts. You increase your effectiveness, but you're decreasing your efficiency, right? Because you increase more alerts, you get more false alerts. It's just the nature of the issue. But if you want to increase your efficiency, then you have to think about, is it still explainable? Because maybe you're using newer techniques, newer capabilities to increase the efficiency, right? The 效率, but how do you explain that to your auditors, to your regulators? And that becomes a headache. So it's always these three concepts that are counteracting and working with each other. And that's the world of essentially, dealing with AML. No matter what systems you use, it's always going to be how effective is my algorithm? How efficient is it? Am I getting a lot of false alerts? And then how explainable are the techniques? Right? So just a really quick introduction because it does go into the regulator guidance as well, right? Because we talk about AML technologies in the world of AML, but then we also have to always under the guiding principles of what the regulators are saying, what regulators are allowing us to do. And the regulators have been, I would say, publishing guidance for a long time and looking at adoption of various AI techniques, starting from the Singapore MAS. The FEAT principles is a good starting place. And this is where also our founder, or not founder, but our CEO, the other David Hardoon at ADI, he was previously with MAS. And when he was at MAS, he had a defining role, right, in authoring the FEAT principles. FEAT being fairness, ethics, accountability, and transparency. So FEAT as a guiding principle at the MAS for AI ML adoption. But it's not just MAS, it's also US FinCEN with the adoption of innovation and newer techniques in fighting financial crime. It's FATF. It's here in Taiwan with FSC issuing guidance. But they all sort of culminate into these 8 sort of principles in terms of adoption of AI techniques and principles, right? So you have things such as transparency, accountability, the ethics, accountability. But I think I want to touch a little bit on explainability, because I think these other principles, they're there. I think it's quite common. You see it, you follow best practices. But I want to touch on explainability a bit, because it's funny, because the more complex the AI techniques that we adopt, so like LLMs, for example, that Wee-Tee touched on, or deep learning techniques, especially when it comes to alerts, using machine learning to generate these alerts, the more of a black box the AI algorithms become. So if you have a black box, how can you be expected to make it explainable, right? And this is where I think that the interesting piece comes in, because it sort of requires us to rethink the concept of explainability, whereas it's not exactly explainable because it is a black box, it's a deep learning technique, but the concept of interpretability, 可理解性, right? So thinking about it as in not how transparent this is and how explainable it is, but how interpretable is it to someone with the technique. And if we look at the evolution of artificial intelligence, that's the way, right? It started off with deterministic approaches, right? Rules-based approaches. Rules-based deterministic is very easy to explain, right? Because it's X, Y. These are the rules. Then you go into probabilistic models, machine learning, it becomes a little tougher. Then you go into deep learning, it becomes impossible. And then you go into Gen AI, and then, just becomes more and more of a black box, right? So it's very important that when we adopt newer AI techniques, and to really maintain regulatory guidance and best practices, start thinking about the interpretability of the processes that you are putting in. So again, it's the 3 concepts, right? People, technology, and processes. So a bit more of a explanation and insight into the interpretability, right? So when you're thinking about interpretability, actually there's some similarities or concepts that could better use, I guess, human psychology, right? Because it's the human that has to interpret the machine. So how can you make it a bit more interpretable for humans? Like, for example, when explaining something, don't use contrast, right? Don't just explain it, but use contrast. So what's a contrast? Don't explain why event P happened. Explain why is it event P, but not event Q, right? Then it becomes a bit more intuitive, right, and interpretable. It could also be something around segmentation. So people people rarely will expect all the explanations, right? Because if you look at a machine model output, maybe you don't care about every single detail, every single segment. Maybe you just care about a specific segment. It's like you're wondering, why does a specific segment happen, right? So that's another way of explaining it. Another one that I think maybe you see more often in financial crime, especially alert generation, is statistics. Because oftentimes you get a probability score that this is an alert, right? That this is a transaction, it's a money laundering alert or financial crime or fraud alert. But in statistics, it's not so meaningful to say, the alert's probability score is, 80% it's money laundering. But it's more like 80% it's a money laundering alert because of attributes X, Y, and Z. That makes it a lot more interpretable in understanding why my model produced this particular score. Even though I don't need to know exactly how the model produced it. So something like SHAP, understanding the data features that contributed to that particular output could be very useful, right, in guiding, especially presenting to auditors or regulators and following that principle of transparency and explainability, especially when implementing more complex AI ML models. Okay. So then taking a closer look and understanding what are some of those AI techniques that are often used in AML. You have obviously there are different technologies, different techniques. Common ones can include things like bagging and boosting, right? These are often used for either generating alerts or reducing false alerts, right, to create more efficiencies. There are other alert generation techniques like clustering, for example. K-means clustering to find anomalies, using graph networks to see those complex money flow linkages and raising alerts that way. Using Gen AI, using these deep learning techniques like clustering and XGBoost. The downside is you need millions and millions of data points or hundreds of thousands of data points, and you need labeled data. And sometimes those can be extremely challenging to come across. Data sharing, the data foundation might not be there. So then maybe using Gen AI can help in creating those synthetic data samples that you need to train your models, right, to augment the model training. And synthetic data generation is not just about generating profiles and fake profiles, but retaining the distribution, retaining the modeling characteristics of your data, right, is quite important. But Gen AI, that's another application of Gen AI and where it can help. We saw earlier with the LLM use cases that WeT presented, using Gen AI, copilots, document as Gen AI, but that could also be used maybe perhaps in report generation, suspicious transaction report generation, or maybe even alert reviews. These are all areas that Gen AI could potentially be applied to, especially if you're able to, like within Cloudera, bring that totally in-house into your own environment, because I can understand AML is a sensitive topic, especially. So this is probably one area that, having a local model with a more robust private infrastructure could be quite useful. Then, of course, the other techniques like RPA, robotic processes, automation can help you with alert reduction and whatnot. But again, the techniques and the technologies is meant to augment and support your processes. And these are just some of the common areas and common techniques that are used when it comes to AML and within the AML framework. So what does that mean, and how does it translate into exactly a good AML process, right, for a bank? And well, for the transaction monitoring system, a modularized approach is probably best. So a modular approach meaning I know that newer technologies and newer techniques are going to be introduced day in and day out. So if I can make my AML process and system modular, then I can always swap in the best of breed, the best technique that are available for me, right, to use so that I can adopt and keep up. And also it's easier on the change management as well. Instead of ripping out in my entire system, I slot in modules that can help me in that process. So it could be something like using those deep learning techniques for alert generation or alert reduction, using graph neural networks to help me visualize money flows and complexities in the money web and alert them. It could be Gen AI, using Gen AI use cases, or improving the overall case manager and user interface, right? So these are the different areas. So as long as it's modularized, then you can slot in and phase in to help you support your anti-money laundering operations. So that's what good looks like, but based on our experience working with some of our customers, we can take a real life use case, right? And take a look at how does it actually translate into the real life situation. So we worked with a bank, a retail bank. Customers were under attack, right? As you know, in certain markets, they get solicited these sort of money for work or scam type of text messages. The customers are coming in and they have account takeovers. They're losing access to their accounts, or they themselves are the ones that are actually working in collusion with criminal syndicates and opening accounts and using it as, money muling type of activities. So money muling being that I myself opened an account where my account was taken over and it's just used for funneling money, right? People are, I opened the account, I put in $1,000, then I transferred to someone else $1,000, right, in quick succession. So when we worked with this particular retail bank, their existing AML financial crime system is, I would say, quite typical. They had an alert generation engine that was based on rules, so tried and tested typologies of money laundering and alert generation. They had these rules to generate the alerts for them. But the alerts were quite extensive, so they applied some basic machine learning principles to reduce the alerts for false positives. They had a case manager, and then they also had an RPA, and a robotic process automation agent that helped them reduce alerts and do the first level of alerts. But however, when they looked at money muling, this specific new typology, they realized that they were not very effective in their approach. They were able to detect zero number of actual accounts for money muling. They were not able to proactively identify anything, right? It actually took their customers to call them and say, hey, what's this activity on my account, for them to actually be alerted to suspicious behavior. And it took them about an average of 43 days for that to happen. So clearly, from a report card point of view, not very effective when it comes to catching these money mules. Well, how did we help? So we looked at it and we said, okay, so one, their alert generation was not very good. Two, also the way that they were managing it through their case manager, managing the alerts, could have used some improvement. And three, is there a use case for Gen AI in that particular scenario? So we decided to take a phased approach and attacked the problem that was most pressing for their situation. So the most pressing problem was actually on the alert generation aspect because they were catching no one, right? So clearly it was a bank that was used for money mules. So we applied some deep learning techniques, tried and tested machine learning techniques that was able to help them very quickly surface a lot more alerts that they were unable to surface before. But because we attacked it in a modular approach, it was not a wholesale replacement of their existing TMS processes, right? We retained the TMS system, the transaction monitoring system. We retained their existing AML processes, but made modular improvements to different elements. So did that first with alert generation, then applied graph network to visualize the money flow, right, and help their end users validate and review the alerts. But then the graph neural network could also be used with the data association and data generation. And then made those improvements to their case manager as well, right? So then as a result of this, we were able to catch 500 plus money mule accounts and sort of just by going live, true identification, reduce and improve their efficiencies by about 90%, and then cut down the number of days, the average lead time, right, between account takeovers and suspicious activity to about 4 days from account opening to identification of money mules. So I think that was a significant improvement, but you know, if you work with AML systems, these are systems that take a very long time to replace. And we're not saying that you have to replace this, but we can help bring in the modules that can help you improve straight away. Okay. So that was quite a useful case. And this is how, I guess, certain techniques and technologies can be used to help them improve existing processes, right, in their environment. So then, looking ahead, formatting here is a bit off, apologies. But looking ahead, I think the important things to call out is what are some of those technologies on the horizon. And as we know from WeT just now, covered extensively on Gen AI use cases. How can we bring Gen AI into the enterprise? And this is a discussion that's going to keep going, right? It is a 42% compounded annual growth rate from here on out for the next 10 years. The adoption of Gen AI and the adoption of Gen AI for enterprise. But one thing we haven't touched on is blockchain, right? Because I think now we're looking at the resurgence. It's another bull market in crypto, blockchain, but blockchain technologies is being used and adopted, right, by large banks and financial institutions. So assets are continuously moving on-chain, tokenization of securities, tokenization of structured debt, tokenization of various assets are moving on-chain. So therefore, the tokenization of these assets equates to how do you comply? So are you looking into the travel rule compliance? Are you looking at DeFi technologies that are being used today? Are you tracing the wallet addresses? And what's going to be really interesting is looking at the intersection of on-chain activity and off-chain activity, right? So how does the money flow from on-chain to off-chain and back on-chain again? And that's where, you know, a lot of existing topologies don't do well because it's still very segmented. You have a set of tools for on-chain monitoring, and then you have your traditional anti-money laundering tools for off-chain fiat movements. But that intersection is going to be an interesting area for sure. Then, of course, there's something called Depin, right? Depin is this concept of decentralized physical infrastructure. So instead of everything being centralized, a central data center or a centralized cloud, there's this new wave of technology adoption that allows you to decentralize that, and anyone with a computer, right, could be used for maybe their excess compute technologies. So using Depin could farm out the excess compute to individual computers. And that could be really interesting because now it enables, a new wave of, the next wave, perhaps, of compute and hardware providers, right? And if this comes online, then as a bank, as an organization, you have to start thinking about, with the adoption of AI, and Gen AI specifically, it's very compute heavy, GPU heavy, then your compute efficiency also becomes a part of your bottom line, right? Increasingly. So the organization that can outcompute its competitors has a competitive advantage. Right? So then that becomes quite interesting. So looking ahead, I would say probably the three most disruptive technologies, you have Gen AI, you have blockchain, and now you have this concept of Depin, right? Decentralized physical infrastructure. So then it culminates, right? Now technology is always going to continue to be disruptive, and new techniques are going to show up every single day. But then it culminates in what I would say this triangle and this concept that touched on the entire presentation, which is people, process, and technology. It's always these three, right? If you think about it. So essentially, your people define the technology, but your people also define the processes. The technology is meant to enable the processes. So it's really important that, whether it's AML or moving things into the Cloudera environment and being able to build AI use cases on top of your data, it's really important to first define what are those processes that you need to improve to gain that competitive edge, and then identify the technologies that will help you get there. So then you let the technology can do the process. So the better your process definition, right, then the bigger the problem you're solving strategically. So WeT covered earlier the LLM use cases, Gen AI. Yeah, you are able to improve your existing processes operations by 10%, 95%, but you have to define those processes first, right? Okay, these are the processes that we want to improve. Then you identify the technologies to take you there, right, to help you enable those processes. So the rule of threes, right? People, process, technology can be applied in this case, of course, to AI, AML, compliance. And then we looked at also what are those techniques, those AI technologies that are often used in anti-money laundering. So pretty much everything culminates in and summarizes what we covered earlier today, which is AI, augmented intelligence, and this is the framework that can help you augment your teams.